Hi, welcome back. Today we're going to do the 20th question. This is a search a 2D matrix. So we are given a m times n integer matrix with the following two properties. And each row is sorted in non-decreasing order. And the first integer of each row is greater than the last integer of the previous row. So yeah, given an integer target, we were supposed to return true if it is, false if otherwise. And we need to find a solution in O log m times n time complexity. So essentially we're looking at this example here. You can see that each row is 1, 3, 5, 7. So it's non-decreasing. It can be 1, 3, 3, 5 because it's non-decreasing. And then we are looking at the integer of each first integer is greater than the last. So it's strictly greater, 1, 10, 23, right? 1, 10, 23, yeah. And so right here we have this solution here, and we are supposed to get just return a boolean value for 3. So we look here, right? So essentially this question is probably a variation of binary search that we did before, and since we are given that it is non-decreasing order, right? So let me just add some comments here. Sorry. Right, since we know that each row is sorted in non-decreasing order, right, and we know that the first integer is greater than the last integer of the previous row, right, we likely can use binary search, some variation of binary search. So to halve the search space each time. So essentially when we are looking at this question, we kind of can think that in a row we have, since it's strictly decreasing, right, we are looking at this 1, 3, 5, 7, 10. And for example, if we're looking at a variation of, we're looking at 9, right? So let's see if we can do this like that, and then let's paste this here, right? And let's form this example here, put this down, let's move this a little bit over here, move this a little bit, and we got it, right? So essentially if we're looking for example, if target is 9, right, and we can tell that target 9 would be in between these two numbers, right? So we need to think about to first filter our search by rows before looking within the row. So what does this mean? Because we know that the target is 9, we have our first element of each row, which is this 1, 10, 23. We are looking at 1 and 10, and essentially since 9 is bigger than 1, we then want to look at 10 to see if 9 is bigger or smaller than 10, right? To know where to search. And if 9 is in between, is smaller than 10, then we know to look for the first row. And essentially the combination of these two properties just tells us that this entire array is essentially sorted in ascending order. This element here will essentially always be, right, smaller than the element here, right? Right, because of these two properties, right? Because of these two properties, we know that the last element in a row is less than the next element, the next first element of the next row, right? So this we know, and then we are looking at this entire question here. So the main question now is to filter our search by rows, and we are looking at this in this case. So whether or not it's bigger than target. So essentially check if target is equals to matrix I, right? Essentially if we matrix I is greater something like this. So we want to check if the target is greater than matrix I0 to filter to know which one of these elements we want to look at within a row, right? And then we have all these elements here to check. So essentially what we want to do now is to perhaps we definitely want to filter our search by rows, so we need to, before looking within the row, i.e. we want to conduct a binary search for elements within among elements for all the first elements. So essentially when we're looking at this, we have, right, 1, 10, 23. So we want to see 1, 10, 23. Essentially the thing we are looking at is 1, 10, 23. And if we're looking for 9, we want to make sure that our search space has to be greater than this 9. We can eliminate all elements that are, we can cut the search space, right? We can cut this entire search space to see if it's 1, right? To see if it's 9 is in, can only be here, because essentially the elements are sorted in non-decreasing order. Okay, so if we have a target that is, say, 4, and this instead is 9, right? So essentially we can also eliminate this entire search space and return false, right? So we want to form an array of the first elements of each row, and then we conduct a binary search in this array to find which row this element might be in, right? We want to make sure we can find all the targets that So what happens if target is 9 and we have essentially a situation where 10 is, we have 4 and perhaps 6 here, right? If we have 4 and 6, then essentially we eliminate 9 because we know that, we eliminate the last row because we know that target will not be in the last row. However, we have 2 rows here and we do not know where to find 9 here. And essentially we are looking for the largest one here, right? Because this is definitely bigger than this, right? Greater than the last integer of the previous row. So essentially 6 and 4 is greater than this, so we need to find this. Yep, so we can essentially eliminate all the elements that are here as well, because it is impossible for us to find target in any row smaller than 6 if we can't find it in 6. Because if we can't find it in 6, all elements before the row, in the row before 6 would be smaller than 6, and hence we cannot find target, right? So essentially we can start our search here. Okay, so essentially now we want to just move very quickly and find and make sure that we have a binary search algorithm, and then when we have a binary search algorithm, we want to find another algorithm to run to find the right index here, right? So we want to have two functions. One, to find the right row to start binary search. Two, binary search row search of an array return boolean, right? This one returns boolean, this one returns index, right? Okay, so let's just, without further ado, let's just start trying to implement this array, this question. Now we have, let's just start from the top. We need to find the right row. Right, we have df find row, or maybe let's just do this right away. Target row. We have yeah, here essentially we have 1 3 5 7. We have an array of the integer stacks. To see columns, right? So search matrix. Rows. So we want to have how can I create the first element of each row? I want to have the first element, so I have rows and then I have first element of each row, 1 3. Matrix matrix. So essentially we're looking at something like this, right? Essentially for range 0 to this, and then we want to create a rows matrix 0. So we have matrix 0 for this, and we create a rows index. Right, first element, first integers, right? So we have a first integers matrix 0 for range 0 length matrix -1. So range 0, we have matrix 0 0. Sorry, this is I, right? Essentially we have the rows and we have the columns, right? And then we have first integers, and we want to run binary search. So let's just create two more functions here. Binary search, right? Which essentially takes in an array and a target, right? And this one we would like to do LR equals to 0, length of array -1, and then we have LR 0 array -1 mid, while L is smaller than or equals to R. We want to initialize mid equals to L plus R //2, and then here we want to make sure that we have this situation here to have middle, and then we want to make sure that we have middle if target array of mid is greater than or equals to target. We want to move left. Array of mid is greater than or equals to target if array of mid is this value is smaller than target, we want to do this, right? And then this one we want to do this. Mid is greater than target means we want to search the left side of the array, and then we run this algorithm again. And then we return -1. If it's equals mid, right? Index of this binary search should be like that. Pretty simple formula. And then here we want to make sure that we can search for an array in the target, right? And then modified binary search here. Essentially we want to have a this is essentially the bare bones binary search where we're returning the index and -1 if the index doesn't exist, if the target doesn't exist. But essentially what we want to do now is we want to find the index of and here we want to have df find row, right? Given an array, a list, and a target, right? We want to find a row that it belongs to, and essentially here we know that it is sorted again, so we want to cut the search space. This part is the same, this part is the same. We have this, and then we want to fix this. While left is less than r, mid is left plus r divided by 2. We have this, and then right is mid minus 1, left is array of mid smaller than or equal to target. We want to return this, return mid, and essentially how do we know, right? Essentially how do we know that it should be in this row? The only way to know if something is in this row is if the target is bigger than this element and the next, and smaller than the previous element. Yeah, so essentially we want to see if the target is like that, And yeah, this is the same. Middle is the middle, and then we want to see now if the array of middle is greater than or equals to the target. So if we're looking at this, if 10 is greater than the target, we want to make sure that right becomes mid. Here we don't want to mid minus 1, we want to have mid. We want to utilize this as well, right? And then here we have array of mid less smaller than target. We have L equals to mid. And then here we will return mid, else return 1, minus 1. Minus 1 here. Find row while left smaller than right. Mid is equals to left plus right divided by 2. Yeah, we need to return something here. We need to find something. How do we know that it ends up? How do we know that 9 ends up in this row? Right. If it is bigger than this, okay, let's change this. F equals to mid. Yeah, this is a bit of a problem. We need to think about how we can find this. But in this case, we are given we don't need the index, we just need to give a boolean value. So 1, 10, 9, if we want to find 9, we need to make sure that we have an element here that can be found, right? So 1, 10, 9, we need to return an index for this. If we have 9, we need to make sure that target is greater than 1, target is greater than 0, and target is greater than the next element. Yeah, we essentially want to shrink down left and right pointers such that we get exactly the situation where left, right, left, where the left pointer is what we want. So essentially now we need to, while left is smaller than or equals to right, let's change this condition to left is smaller than right, okay? And then we want to make sure that mid equals to this, yes, and then we want to make sure that here we want to return left, right? And then while left is smaller than right, mid is this, array mid is smaller, greater than target, we want to shrink down right equals to mid minus 1, left equals to mid plus 1. Let's try this algorithm out right now. Yeah, essentially we have a situation here that is 1, 10, 23, right? 1, 10, 23, or let's just do something then. And then we have this left and right here. And then mid is left plus right. 0 plus 2 divided by 2 is 1, right? So mid is here, right? And then we have if array of mid is greater than or equals to target, mid. Target is 9, right? 9. And since we know that array of mid is greater than target, we want to shrink right equals to mid minus 1. Yep. So this becomes left and right, both are here, right? This one becomes mid -1, and then the condition breaks here because left and right are both equals now, and we want to return left. Yeah, essentially we want to return left pointer here. And here we have left and right pointer. Let's try with a larger example. Perhaps let's try with 10, 11, 16, and 20. And assuming our target is 18, right? Let's assume our target is 18. And we have left, and we have right here, and we have middle. So 0, 1, 2, 3, 0 plus 3 divided by 2, it's integer division, we get 1. So it's rounding down, we have middle, that's in 11, right? So middle is in 11, right? And then since middle is in 11, we need to look at this like that, and then middle is here, array of middle is smaller than or equals to target. So array middle is smaller than the target, we want to shift left to mid +1, so left becomes here, right? And then now we have this, left and right here. We now want to make sure that left and right is here, and then we have mid equals to left plus right equals to 0, 1, 2, 3. 2 plus 3 divided by 2 is 2, so we get 16. So mid is also here, right? LM is here, and then we have mid here, and now we are looking at array mid equals to target. Array mid is smaller than or equals to target. It's still smaller than the target, so L equals to mid +1, so we have left here. And essentially, since we have left here, L equals to mid +1, left plus right is the same thing. We are searching 18 in target 20, which is wrong. Yeah, I think that's all for this question so far. We have, I guess the concept and the solution, the thought process is correct. However, we just need to think of how we can solve this better and perhaps revisit the solution again. So yeah, that will be all for today, and thanks for watching.